Hello guys, welcome back to my channel Plan 3D tutorial, and in this video we'll be learning about structural modeling in Plan 3D. So once you watch this video, I can guarantee you that you will be very well versed in structural modeling in Plan 3D. So I request you to watch this video till the end without skipping any part. And also, if you like this video, please like the video and subscribe to my channel. And if you haven't watched my previous videos of equipment modeling and piping modeling, please do watch that videos as well. So let us begin with this structural modeling video. So here we are in our structure modeling ribbon bar of Plan 3D. Here you can see in the top part, if you have to model the structure, you have to select the structure in the menu bar and our structure ribbon bar appears like this. So first what we will do is we will first learn about this member settings, and then we'll start from here and learn members, grid, everything, and next at the last we'll learn about the modifying the members, that is cutting part, which you can see here. So first, going with the settings, if you see the settings are basically used to select the type of members, size of members, or the standard of members which we have to follow. So here if you see in the setting bar, we have member, railings, footings, stair and ladders. Member setting is used to modify the size of a beam or whatever member you have, and the rail settings is used for railings. Foot settings is used to modify the footings. Same case goes for stairs and the ladders. So first we'll see about the member settings. So when you click the member settings, here you can see the shape standard, then shape type, shape size, and other standards here. Here, starting from the shape standard, here you can see there are AISC, CISC, DIN. These are nothing but standards of the beam or whatever members we are using. These standards actually change depending upon the country which the plant is being set up. So based on the country code, you have to select the standards. So first, if I select DIN here, you can see here flat shape, HEA, HEB, I-beam, L shapes, and different types of members which we'll be using in the plants. So whichever the member you need, you have to first select here, and then you can use the member in the Plan 3D. For example, I'll select HEB here, HEB 500, which I'll be using later in my video. And next, material standard. Material standard is nothing but the standard for the material. You can see here ASTM, BS, and DIN standards, European standards. And next is the code of the material. Every material will have a code. So based on that code, the codes are given here. If I change it to ASTM, the codes change here. So based on this material standard, material codes will be displayed. So next is the angle at which you want to drag the member. For example, I can change the angle here, or I can enter the angle as well, any random angle as well. So I'll just keep it as 0. And next you can see here we have written horizontal and vertical. Before this, you can see here there's a blue dot here. I can put the dot anywhere here as well. So you can see when I change the dot, these values also change. See, this dot is actually the drag point from where the member will be dragged, whichever direction you will pull it, in horizontal or in vertical. Like this is the drag point. From here, if you pull in the vertical direction, or your member will be pulled. If you select this as your drag point, your drag point will be this. So even this, if you want to change the drag point, for example, I want to keep it as 200. You can see my drag point is here. So by varying this, you can change the drag point. Right now, and most of the time, we will not be using these things in our structural modeling. So I'll keep my drag point as center. And about these two, you do not worry about this. You can just neglect these two. You don't need to change anything here. So you just have to know this is the basic part of member settings. So if you want any T shape, you can get it here. L shape here. If you want IP standard of beams, you can get it here. Okay, this is all about member settings. So I'll click on OK. Next we have rail settings. Rail settings is nothing but the railings which we'll be using in stairs or anywhere where there is a risk of falling down. So we'll be using rails there. So the dimensions of the rail we'll be setting in the rail settings. I need not explain this, I guess, because you can see it is very clearly and easily mentioned here. What is one? One is the handrail of the top. Here you have to write the height of the handrail. Height of the handrail from the bottom of the rail till here, what will be the height will be given here in the 1. Here it is written as 2, that is first mid rail. What will be the height of the mid rail? Here it is written as 550. Then second, and next kick plate. Kick plate is number 4, which comes at the bottom. So what will be the height of the kick plate is given here. Next is the first post. First post is the vertical bar, which will be welded to the horizontal bars of the railings. So what is the first post distance? It is given as 250, and the next second post is like this 6, that is distance between two vertical bars, that is 1500. And next here the shape of the handrail, you can change it from here. If you want a pipe or L shape or IP, same like how you have changed in the member, you can select the different types of members for the railings. Next, the type of member you need for the first mid-rail can be changed from here. And next it is middle rail continuous. Middle rail continuous I'll explain you when we are modeling the rails. The next, size of kick plate, and last we have the post. Post is nothing but, as I told you, the vertical bars. The size of the vertical bars can be set by changing this setting. So this was overview of the rail settings. And next we have the footing settings. Footing is nothing but the foundation on which the columns will be supported. So the length, breadth and width of the footings can be set here. For example, I'm giving 500, and depth I'll be giving it as 350. These are just random values which I'm giving. So if your footing is of concrete, you can set it as concrete. Then if your footings are of different material, you can select the material, and the standard of that material you can select it from here. Okay, so I'll change it to concrete and click on OK. So that is about footing. And next we have stairs. Stair setting also, you can see the numbers have been given and the respective dimensions you have to enter here. For example, the width of the stair is 1. What is 1? This is the width, and whatever width you want as per your plant size and the space available, you can enter here. Next, the maximum thread distance, number 2. Distance between two steps, it is giving as 250. And the next, the step data. When you click here, you can see the size of the step, like 1, 2, 3 are there, numbers are there. You can see what is 1 is 70, that is the thickness, 2 is the width, and 3 is the chamfer. So like that, you have some standard step sizes available here. Either you can select any of the standard step size, or you can change the values as well. But in standard, these are the values. Okay, I'll just cancel it. So this is just what the stair setting is. And at last we have the ladder setting. See, ladder setting, we have two settings here, ladder and other is cage. For ladder, you can see again we have very easily explained over here. The numbers are given here and the values, respective values have been given here. So whatever the size of the ladder you want, like 1 is 500, 2 is 800, then projection is 1000, that is 3, and next long run distance is 250, that is distance between these two rods. If you have any description for the ladder, you can give it here. Again, you have whatever the shape of the ladder you want, you can change the settings here. The ladder is this horizontal bars and the rung shape is this vertical bars. So you can change these two values over here. Next we have cage. We have the description of the cage, if you want you can give, and very easily again it has given the numbers here and the respective values over here. You can see 1 is the height of the ladder. So 1 here it is given as 2800. This 2800 means, so once you started your ladder here at 0, for example, after you go at a height of 2800, your cage will start. Below that you will just have a ladder. After the value of 2800, that is height of 2800, your cage will start. In the other values, you can see 2 is the distance between these cage supports which are welded to the cage, and in the same way you have the numbers and the respective values here. So this was about ladder and the cage. So I hope you understood the setting parts of our structural elements. So now let us go with the modeling of our structure. So now to begin with our structural modeling, first we'll make a grid. Grid is nothing but a 2D line representation of a structure. Here if you can see, we have some axis values and the axis name, and I have entered some different values here. So what I'll do is set my coordinate system to WCS and just click on create to give a better understanding for you. Here when I click the grid here, you can see there are three values, 0, 6000 and 12000, and the axis name is local X. X is this axis here where I have given three values, that is this is 0, this point is at a distance of 6000, This point is at a distance of 12,000 from our 0, and the name of the points what I have given here is A, B, C, which has been displayed here. And in the same manner I have given some values in the row value, that is 0 and 6,000. 0 is this point and 6,000 is this point, and the name of the axis is y axis. Along the y axis you can see here local y. So name of those points is 1 and 2, which is displayed here. 1 is 0 and 2 is 6,000. And the next is the platform value. Platform value is nothing but the height of the structure. Height, you can see it is 0 and 3.5 meter. You can see here 0 is this point and the next point is at 3,500. If I add another height of say 7,000 and give the name as a plus 7,000 and click on, sorry, I have to modify it. To modify a structure you have to go at modify structure. So here if I add another level, that is 7,000, and name the level as 7,000, okay, you can see that one more level has been added. So I don't need that level now, I'll just undo it. So now what we will do is we will add columns in our vertical lines and beams in our horizontal lines of this grid. Now we have to add members to our grid, that is members can be added from this member icon displayed here. And its settings I had shown you in the beginning. I want a HEB 500 beam. I'll keep this peak point at the center. So now I'll click on member and I want a vertical column here. So what I'll do is I'll click this end starting point, and the ending point I want to be it here. My beam has been generated. Here you can see the center of the beam is lying on this on the points which I had selected. So that indicates this point. This blue color dot indicates that selection. So if I set the dot to this top part and click on OK and then click on the member and I'll add a beam at this corner, you can see that the points which I had selected, middle of the top flange of the beam is resting there. If I show you the top view, you can see it here. You can see the difference between the two. Here the beam is resting at the middle, here at the middle of the top flange. I hope you understand what this point means now. So I'll click on the center point and click on OK. So either I can copy the same beam here or I can create the new beams. I'll just copy now. 6,000. Okay, my columns are ready. Now I have to put the beams. I'll click on member again, but now I want my selection as this point. Now I am putting a horizontal beam and this top of the beam I want on the line. So I'll click on member. From here you can select the end of the line, and here my beam has been generated. So I'll just copy the same beam everywhere. Okay, and I want on horizontal beam here, this point till this point. Here if you see the representation of the beam, it has too many detailings. The representation we can change it from, you can see here shape model. Shape model, if you click, we have line, symbol, outline model and shape model. Here if I click on line model, you can see we have lines and there is one symbol of the beam. The detailing is less here. If I click on symbol, you can see it is a line in the shape of the beam. Same case outline covers all the edges, and the shape model shows the beam with more detailing. So I'll just keep it as a outline model so we have less confusion. So I'll just copy the same beam on the other side as well, 6,000 and 12,000. So here you can see our structure is ready. So for this structure what I need is I need a grating plate over here, then I need a railing, then I need a staircase. So we'll be utilizing all these applications in this small staircase. See, I'm using very small structures or else I'm using just a single pump and equipment for modeling piping and to explain isometric is because I need you to understand the basics with very clear manner, because in the future we'll be doing some complex piping as well, complex plants. So once if you don't know the basics of the Plant 3D, then it will be difficult to understand the commands in the future. So we'll go step by step from basic, then we'll cover the high-end plants and critical piping. So now we'll be adding the footings to the column. See, footings can be added either at the beginning or at the last, or as I'm adding now after creating the structural columns. So now I have set the footing settings as 500, 500, depth is 350. Okay, I won't change that. So now to give the footings, I'll just click on footings and the point where I want the footing to be placed, that is one at each column. So here you can see my footing has been placed. This footing looks a little bit smaller, so I'll just increase the width of the footing. Footing width is actually based on the size of the column being used. Okay, I'll just give it as 750, and height depth I will keep it as same. Okay, I'll place the footing now. This looks fine. So next, okay, I will copy the same footings everywhere. Okay, so our footings are ready. I'll just show the shaded part how it looks. See, this is our structure and this is our footings. We'll keep it in wireframe. Okay, next what we need is a grating plate or a checkered plate. See, first I'll tell you the basic difference between the grating plate and checkered plate. See, here you can see this is how a checkered plates look like. It is just a solid plate with some checkered pattern for grip purpose. And next, if you see grating plate is like this, which is not fully solid, as you can see here. So this is the basic difference between a checkered plate and the grating plate. So now what I want is plate. I click on plate. Here you can see it is asking me a plate or a grating. So I need, first I'll just use it as plate, the standard of the plate, the material code, the thickness of the plate, you can select it here. I'll just give the thickness as 10. And this justification point we'll learn while creating the plate. This you can see I am clicking it as a new rectangle. So when I click it as rectangle, I have to draw a rectangle and my plate will be created. If I keep it on solid, you will be able to see my plate is created. And next, if you see here, new polyline. New polyline, if I click, I have to draw shape of the plate line by line by selecting the points like this. And here it's done. So this is the polyline. And next here I'll just first draw a rectangle and next go to the plate. Next it is asking me existing polyline. If I click on existing polyline and click on create, it will ask me to select the polyline. See, here I have created a polyline, that is a rectangle. So if I select this and click on enter, my plate will be created. Okay. So these are the three differences between this shape. So I'll just select the new rectangle now. Justification I'll show you. See, I have selected top as the justification and I am clicking on create. When I click on create, I want my plate to start from this point till this end of this bay point. Okay, so I'll click on this point and next I'll click on this point. See, my plate has been created. And the justification point means, as I've selected the end point of this, the top of the plate is coming on my selection. If I'd selected the middle point and then create the plate from this end till this end, now you can see my middle of the plate is at the selection points. Here you can see my top of the plate is at the selection points. So this is the basic difference between this justification. If I select the bottom of a plate will be coming at the selection point. Okay, fine. Okay, we'll delete this plate and now we'll add a grating on the other way. Grating, same thickness, material code, this justification remains the same, and these three functions also remain the same. And the pattern of the grating, there are different standards of patterns you can select from here. I'll just select a hexagon pattern, hexagon hatch scale, we'll keep it as 10, no problem. I'll just click on create. See, basically you do not worry about those things, I'm just telling you this for the basic understanding of the software. Okay, I'll select the hexagon here at this point, and one more point is this. Okay, I'll just keep it in shaded. See, here if you see, like both looks the same. So here if you change the pattern to shape model, then you will be able to see the difference. Plate is being displayed as solid, but the grating has been changed. As we had selected the hexagon pattern, you can see the hexagon pattern being displayed here. If you had selected the other pattern will be displayed. So this is the basic difference between plate and a grating. And next what we need for our structure is the staircase. For staircase, as you know, we have already changed the settings here. And now when you click on the staircase, it is asking to specify the start point. When I click here, now it is asking me specify the next point of the staircase. You can see here specify the next point of the staircase. So if I click here, a line is coming, then again I have to select the next point. So after selecting all the points, when I click on enter, my staircase will be generated. Since it is horizontal, my steps are not seen here. Personally, what I do for creating a staircase is I actually first I draw a pattern of staircase in lines, like the route which the staircase will be following. For example, here you can see, which I had drawn before, this is the route staircase has to follow. That is, first it will go up, then we have a landing, then again up, then again we have a landing. So this helps me to create the staircase. Here I'll just click on the stairs and I'll just follow this path. That is, click on this endpoint, and this endpoint, and enter. This is as simple as this. Then again click on this endpoint, this endpoint, this endpoint, and this, and again my next staircase is ready. So here I'll just have to move it towards the structure, or I'll just move it for 1000. See, my landing is this and my staircase is ready. I'll just delete these lines now which are not required, and next we will move this towards the structure. We'll move this till here around 1 meter. Okay, next if you want you can add a column for staircase as well. Let us just copy the same column, 40 meters. Okay. And next we will give a structural member to support the stairs. Select this point and this point. I had selected the y coordinate of the end of this beam. And next, if I want to modify this, I'll just click on here. Okay, we have created the column, and here you can see this beam looks big. Like, if you just want to modify this beam, what you can do is you can click on this beam, go to the properties. You can go to this properties and scroll down, and you can see here, if you click on this type, you will get into the settings. Now let me just set it to HEB 200 and the same pick point, and click on OK. And you can see my beam size has been changed here. In the same way, if I want to change this beam size, I can do that also by just clicking here and getting into the properties. I'll just move the same thing to the top. So okay, now my staircase is ready. So next what I need for this structure is I want railings for this structure. Railings, I have to just click on the railings. How we had selected the points for the staircase, in the same manner we have to select the points for staircase. Like, I want staircase to start here and then end my staircase at this point. See, my staircase has been created. So again, if I go to staircase, we have one more option here, select object. What happens is, if I click on select object, it is asking me to select an object. Then if I select this beam, you can see my staircase has been created automatically. That is, the railing has followed the path of this beam and it has been created. In the same way, if I select this beam and this beam, my staircase will be ready. If I click on this staircase, by selecting this drag points, I can move this, change the length of this staircase as well. I'll just click, I'll just keep it till this end, so I have space for the entrance as well. Okay, and I'll extend this staircase till here, extend this railing, sorry. So this is how we create the railings. In the same way, we want railings for the staircase. So we'll click on railings and click on object. I'll just click on the stairs, this stair. Okay, Here if you see, we don't want this railings which it has created. I'll just delete this, and we don't want this single railing also. So now you can see it has beautifully created the railing. Again, this railing, I want one railing here. So our railing is created here as well. We'll just extend this railing till the middle part. So guys, this is how we model the structure in our Plan 3D model. So in this video we had learned about the structural modeling of Plan 3D. In our next video we'll be learning about how to trim this, because I don't want to make this video very long. Already it has become very long, then I don't want to extend this video now. I'll just end this video here, and in the next video we'll be learning about how to use these commands like trimming the members and rest of the stuff. So if you want to change the colors, you can go into properties, change the colors, the layers, whatever you want you can keep. I'll just give this members. I'll just give the members, okay? Railings. It doesn't know. It's a personal preference, what color you want you can give. You can select the colors from here also. So we have changed the colors. These are just random colors. You can give whatever color you want, or if you have any standard for that you can change according to that. And also you can add plate for the staircase as well. Okay, let me add it now. Create from the mid of this point. This is the grid end. See, my plate has been created, and in the same way I can create the plate here. I'll keep the justification as top, mid till this mid. Okay, so my plates are ready and our structure is complete. So guys, this is all about structural modeling in Plan 3D, and as I said, in next video we'll be learning about how to modify our structural elements. So if you like this video and if you have learned something from this video, then please like the video and subscribe to my channel. And if you have any suggestions for my videos, then please do comment in the comment section. And also if you have any doubts, then do please comment in the comment section. Thank you for watching this video, and I'll catch you up in the next video. Till then, goodbye and take care.